would have gotten that B would have been easier.
All right, so the first part, A, says show that dy dx equals negative x plus 1 over 2 times y cubed plus 1. First thing we do is we differentiate. What's the derivative? Derivative plus
4y to the third dy dx.
Plus
4 dy dx.
Equals. You get 1 point for that. No manipulation, nothing else that you can implicitly differentiate, you get a point. This was only 2 points for part A. The second point comes in the verification. Can you manipulate this to make it look this way? And can you do so the right way? All right, so remember, I'm going to try to get dy dx by itself on the same side. So I'm going to move these two. We all agree? All right, 4y cubed dy dx plus 4 dy dx equals minus 2x minus 2. Factor out the dy dx. Leaves me with 4y cubed plus 4. Oops, my hand's getting ahead of my brain. Divide both sides by the 4y cubed plus 4. Now remember what we had to do, what it had to look like, right? We had negative x plus 1, 2 times y cubed plus 1. That's what I got to get back to looking like. So let's take out some. I think I'll take out, since this has got to be x plus 1, and there's a negative in front, I should probably take out a negative 2. It leaves me with x plus 1. I'm looking really close to the numerator now. Take a 4 out of the 4y cubed plus 4, and it leaves me with y cubed plus 1. 2 divided by 4 is a half, right? So I end up with negative x plus 1 over 2 y cubed. You went ahead and took out a 2 from everything? That's fine. Yep. Just needs to be, yep. Perfect. Yep. So that's another point. How many did y'all get for part A? No, you can do some of it in your head. You can do some of it in your head. That's fine. So yeah. Which whole chunk? And you could have at that point. But if you factored out a 2 at that point, then you'd have x plus 1 plus 2y cubed dy dx plus 2 dy dx equals 0.
They're all different terms.
So you still always, when you're implicitly differentiating, always get dy dx, all of those on one side and everything else on the other, so that you can get it by itself at one time. All right, so 2 points there, y'all okay? Now the hard part. Oh, B wasn't hard? Okay, B was another 2 points. Oh, yeah, C's the 3. Write an equation for the line tangent to the curve at the point negative 2, 1. It does not specify the form that it needs to be in, so note that. All it says is an equation of the line. Well, the slope is the equation of the right, and they gave that. So even if you didn't get part A, they gave it to you initially in the problem. So use that. 2y cubed plus 1. So I'm just going to find the slope at that point, negative 2, 1. So it would be negative 2 plus 1 over 2 times 1 cubed plus 1. What you mean? You could, I'm in the habit of doing this, finding the slope first. You get 1 point for correctly identifying the slope. And then you get 1 point for the equation of the line. I always find the slope first separately. I get lost in. But yes, if your slope is right in your equation, you get the point, even if you plugged it in. So this would be negative. This is negative 1. This is 2 times 1 cubed plus 1 is 2. So I get 1/4 for the slope. So that's a point if you have 1/4 for the slope. Even if you didn't pull it out and do it separately, if you did the slope within the equation, that's okay. We know the point, right? So it's y minus 1 equals the slope times x plus 2. I'm really surprised they gave you a whole point for that, because that is just, but that's what they asked for, is the tan line. So using that slope. So this is a point, and this is a point. On this one? Nope. It did not specify the form that your line needed to be in. So I would leave it like that. On their answer key, they solved it for y, so they had y equals 1 plus 1/4 x plus 2. But either, I mean, it doesn't matter. Yeah. I put this and just left it like that. Don't even get past A. Yeah, you have to get the specific slope. But remember, just because you can't answer part A doesn't mean don't go on to the others. You could have answered B. You definitely could have answered B. Okay, but even if you didn't, so it's 2, 4, 6, 8, 9 points. That's an easy 4 points. You're already at almost 50% just from part A and B, right? So, and that's what you need to pass, right? So keep that in mind, and you'll be surprised some of these things you get points for on the harder ones. Okay, part C. Listen, if you have absolutely no idea what to do and nowhere to go, write something down. I don't care if you take the derivative of a derivative or if you write something down, because some of the things you get points for are unbelievable. Find the coordinates of the 2 points on the curve where the tangent to the curve is vertical. What does that mean? First of all, where is a tan line? Where is a tan? So where does that occur? What equals 0? But no, it is the denominator. It's the denominator. So it's.
Wait, I thought it was.
The horizontal asymptotes are top heavy, bottom heavy, same. When 0 is on the bottom, it's undefined. That's a vertical asymptote. So. Okay, so, and if you did, so 2y cubed plus 1 is equal to 0, right? The point comes in, if you have this anywhere on that answer, you get a point. If you knew it needs to happen where y equals -1, that is 1 point. If you did nothing else, but you set the bottom to 0 and you solved because you knew vertical, I'm thinking asymptote, bottom to 0, solve. You get a point.
How do you get 2y cubed plus 1 and you get y?
That's the bottom of the.
What do you mean? I don't understand.
Where is your slope undefined? So your slope would be undefined whenever it's completely vertical. Because a vertical line has an undefined slope. I said the denominator of the derivative, so this is the slope, right?
You got -1 by default.
right? Where is that slope undefined? Where am I vertical? Well, it's only undefined when the bottom is 0. You don't have to, the top being 0 would be a horizontal tangent, right? Remember, when the derivative equals 0, I'm at a horizontal tangent. If the derivative is undefined,
No, you do this. R by 2 equals 0. Yeah, I mean, you divide by 2 is confusing. Subtract 1 is plus negative. That way. Yeah, hold on.
okay, so that's where that bottom is 0. If you solve this, you divide by 2, you subtract 1.
Just do it real quick.
Okay. I'm sorry. I didn't realize that's what y'all were stuck on. All right, so divide by 2. Cube root of -1 is -1. Remember, this is a non-calculator, so all of these computations should be really easy for you. If you get into something that's not, you've probably done something wrong. Because they are set up for non-calculator. Dylan, I am going to joke you in a minute. All right. That's not the end of it. It says find the coordinates of the 2 points on the curve where the line tangent to the curve is vertical.
You can plug that Y value back in.
So what happens, plug it into where for what?
Yeah, plug it into your derivative of 5x.
The original equation, because I'm looking for, so I know that at y equals -1, this is the place where I have a vertical tangent, okay? So I go back up to that original equation, which is x squared plus 2x plus y to the 4th. If you don't cut that crap off. And I'm going to evaluate this when y equals -1.
It's not asking about 2 points. It's asking about 2 points.
Correct. And if you look, what happens when I plug in -1? I get -1 to the 4th is 1 minus 4, right? I look like I have a quadratic setup, right? Which makes sense because it said 2 points where that happens. -1/4, yeah. Well, because I didn't want to rewrite it because I'm being lazy. And then if I move the 5, so I end up with x squared plus 2x minus 8. If you did this, if you just plug -1 into the original equation, that's a point. That's okay. I told you when you saw it, you're gonna go. Don't ever give up when you read A and can't do it. Never. Because there are many times when the others do not. All right. Factor this, +4, -2. You do. And what did it say?
What's the 2 points?
Find the 2 points. But listen, you don't get a point for this. You don't get a, because it said find the coordinates of the 2 points.
So you just plug those in.
So you got to give the coordinates of the points. Remember, the y is -1, so it's -4, -1, and 2, -1. You have to write them as coordinates, so your answer there is worth a point. So that was a 3-point question. That was the tough one. There's always one tough one there, and that was the tough one. So, yeah, 1 point for knowing that it was at y equals -1. I'm going to give y'all an answer key after, so you can have it to keep with this always. So if you want to go back and practice any of them. You can score your own. 1 point for subbing that into the original equation and knowing to do that, and then 1 point for the coordinates
Now, what about
themselves.
for this last part? Would you set would you set x to 0 or something?
Okay, so not x to 0, so let's reason through it, okay? So part D, and always read the whole question before you start answering, okay? Is it possible for this curve to have a horizontal tangent at points where it intersects the x-axis? Explain your reasoning. So I'm asked two different things there, horizontal tangent and intersecting the x-axis. So where do horizontal tangents occur? Not asymptotes, horizontal tangents.
Oh, top is 0.
When the top is 0. When dy dx equals 0. Do you agree? Okay. So in the case of our dy dx, which is, I don't know why I can't remember the written this, negative x plus 1 over 2y cubed plus 1,
Yeah.
I'm talking about where this is 0. Do you agree?
Yeah.
Okay. So where is this 0? Get a point for that. You divide by negative 1.
Oh, yeah.
You know, I look at on my
What?
well, it's still there, so I just
It's not under the right part of it.
got that one, yeah.
Yes, it matters.
All right.
So if you do that, you actually subtract.
Now the question is, when does, because remember there was two parts, horizontal tangent and where it intersects the x-axis. So the question is, does it intersect the x-axis here, and how do I know?
Well, is that one first of all?
It would be where y equals 0. So tell me what you did before I tell you what I would do.
Well, I would
What would you do?
I would set on the original equation. So, you have to plug in 0 for y in the original equation.
0 for y and negative 1 for x, right?
Okay.
If that holds true, then yes.
That's like finding.
So what I'm essentially asking is, I'm asking, does it cross here? In other words, is this an intercept? Well, to know that, if I plug in 0 for y,
Wait,
and I
did you
plug
it into that's a y.
no, you want to go back to your original, because that your other one is your slope. I already have what I need for my slope. I know when it's 0. So now my question is, so back to the original, x squared, so negative 1 squared, plus 2 times negative 1, plus y is 0, so 0 to the 4th, plus 4 times 0 equals 5. And this is my big question. Does this hold true? So this does not equal. So therefore, no horizontal tangent where it crosses the x-axis. Yeah.
Didn't we already do a note that we y, negative 1 for y, and then we factored it and we found this was 0? It's we know this is the blanket, we already know that was there.
Where did we factor in prime zeros? Well, that was with the derivative. So that's only to do with the slope and not the original equation, I think is what
No,
you
it's right there, x plus 4x minus 2.
That's only when y is negative 1. If it had been the other way around, yes. But that's only when y is negative 1. Okay, so 1 point for knowing that it's x equals negative 1, or knowing that it's y equals 0. If somewhere on there you had y equals 0 because you knew that was the intercept, that's what I said, write something down. If you literally worked with, it says works with x equals negative 1 or y equals 0. Doesn't matter what work you did with it. You knew one of those two things had to happen to get a point. And then you're...
Well, no, wait, Mr. B. If you only knew that y equals 0 though, you wouldn't know to plug negative 1 into that equation.
Say that again.
Like if you only knew that y equals 0 and you didn't know x equals negative 1, then you wouldn't know to plug negative 1 into that equation.
We're just going to work through. I got you. Questions about your homework? Yes.
Number 44.
44. 34.
Okay.
Which of the following could be true if so you have not learned integration yet, so you can't go backwards. So the only option you have for this one is to take the derivative of each one. What's the derivative? Close. 4 times
Wait, if it's 4,
1/4
or just sorry, if it's 4, does that mean that
to the negative. So could that work? Part A could work. Yes. B, could it work? And this is, if you haven't figured it out, this is setting you up for whenever we do integral soon. Part B, G, could the third derivative of t, by the way, let me go backwards here. Does it matter what this is as you find the second derivative? No, because the derivative of a constant, that's called our constant of integration, and that's going to be a pain in your booty when we get there. All right, so could the third derivative of this be -4 over the 4th root of t? So to do that, I have to go back to the second derivative and say, well, the third derivative is actually going to be, well, this is t to the -3/4. Do you agree? Yes, Ms. McGee, we agree. So let's do the power rule. -3/4 t to the, what's -3/4 minus 1?
negative 1/4. No, sorry. No. Sorry.
-7/4.
Yeah, 7.
So no, that could not be. Then part C. Could the original function be t minus 7 plus 16/5 t to the 5/4? Well, we were given the second derivative, so let's find the first, and then from the first we'll find the second. First derivative, 1 plus 16/5 times 5/4 is 4. Okay, there. And, well, we kind of already did because we did it here, and we said that that constant doesn't matter, but we'll do it anyway. The second derivative here,
Plus, sorry.
so 0 plus t,
Well, it's just the negative.
does that work?
I don't know. I think so. But,
Where? Come out here. 1 plus 4t to the 1/4. So that's 0. So it's 1/4 times 4 is t. Yeah. So if you go back up, it does match. It's t to the -3/4, so it matches. Part D.
Wait, it said that's 1 over.
Part D, the first derivative Could it be 1/4 t to the 1/4? That would be no, because what did it give us? It gave us the second derivative. If I did the derivative here, I would get 1/16 t to the negative 3/4. So,
Don't forget this, we can click on these on Monday.
other questions about your homework? Good. 27. Find the first and second derivative. All right. First derivative, so 2x plus 2y. Remember, I need the dy dx because I took the derivative of y, and now I am just going to get the dy dx by itself. So 2y dy dx equals negative 2x, and I am going to divide by 2y to get dy dx equals negative 2x over 2y. Of course, the 2's will cancel and leave me with negative x over y. So now the second one is the one that gets a little bit harder because I have to do quotient rule. So second derivative here would be derivative of the top. What is it? Negative 1 times the bottom minus top times derivative of the bottom all over the bottom squared. So this is negative y plus x dy dx over y squared. But remember, I want to take this and substitute in because my derivative can only have x's and y's in it. So I get negative y plus x, negative x over y squared. Okay. All right, so I've got negative y plus, actually I'm going to make this minus, x squared over y. It would be okay for you to leave it there. If you needed to simplify it, I could make these have common denominators by giving both of them a y here. So this would be negative y squared minus x squared over y. That's the top, right? And since I've got a fraction and a fraction, I'm going to multiply this by 1 over y squared instead of writing it as a complex fraction, just because it's a little prettier. And so that would give me negative y squared minus x squared over y to the third.
Wait. Oh, wait.
And so that was so the purple is the original, right? All right, so I took the top and I said, let me make them have common denominators, so I put it over y. So it's really negative y squared over y minus x squared over y.
Oh, so you put that one to negative y plus x over y as well.
Yes.
Okay, so you can actually.
Well, no, so then this is the top. I did top times the flip of the bottom. From the purple to the red. Okay, so this is just the top. That's where I had common denominators, right? So really this was still over y squared, but instead of dividing that fraction by y squared, I said, I don't want to do that. I'm going to multiply by 1 over y squared.
Before I got negative 1 y minus negative x times negative x.
You got negative 1y minus Okay, that's exactly what we have. If you multiply the x and the x over y, you get x squared over y. I just did top times top and bottom times bottom. The denominator. That's the denominator here. Let me write that out for you. Let me see. And then I just forced common denominators. Why? You look like you're fixing to fall asleep. You good? Got a paid gig though? Well, then it's worth it. You good? Other questions?
No, ma'am.
Well, we're just going to work problems from your homework. So everything we do together will just be less from your homework. That's the goal for today. Monday we'll start the new lesson. But you still have homework. We're going to work through some of the problems together. I hate to give it because y'all are going to fuss because it's going to look like a lot. But the plan is to work through.
We have the ACT tomorrow, college applications. I don't know why applications. Huh?
I don't understand why all of y'all do all these applications.
Because like half of them are just not plugged in.
Yeah, like half of them have loads of. Oh my.
Because I don't know, like, where I'm gonna get, my state.
That's all.
Almost. All right, we're going to work through as much of these as we can get through before.
That's a lot. Yeah, they sent me a text on why they did a text message. No, I saw an ad. Oh, they sent me a text.
Oh gosh, if she just no, that was canceled. Because they're testing. All right. Your homework's up top. We're going to start working through several of them together. So the directions for 17 through 26 are find the lines that are tangent and normal to the curve at the given point. Okay, tangent and normal to the line at the given point. So that means we have to find derivatives. Yay! Huh? Yes. We'll have to do product rule and chain rule here. So let's just run through it. Derivative of the first is 1 times the second.
Are you still going to sign for our
Shut up, I'm not doing that.
$500 for basic. And we'll pay for it.
Derivative of the left side there
Times really outweigh the pros.
time equals derivative of the first would be dy dx times the second. Oh, I can come?
Yes.
Oh, yeah. Then I definitely still have a job, right?
Yeah.
No
It's a
way.
family event.
Plus the first times derivative of the second. Chain rule, of course, still applies.
I think this would be a great yes for us. But it's not gonna matter.
Okay,
And at least half of us will be 18.
I am not doing that. This is the x and the y that I am using, and so I think at this point it's probably easier, rather than manipulating it the way it is, it might be easier to go ahead and plug these values in now and then solve for dy dx. That's my opinion. If you would rather get the dy dx's on the same side and everything else on the other and then solve, you most certainly may do that. To me, that's a little bit harder, but it's okay. Whatever you want to do. Yeah.
Could you at least explain why you...
Because I'd have to move these.
I'm talking about seeing the...
Dylan? No, I'm not doing that. I'm still not signing for it.
Are you going to come visit us?
No, I probably won't do that either. I don't want to see y'all like that. Okay. Two.
What's she talking about?
I know y'all. Pi over 4 cosine. Ooh. dy dx. This is where you're gonna have to know your unit circle.
Remember what?
Now, if you didn't want to do all this and you really wanted to, this is times 2. What is, all right, so 2 times pi over 2 is pi, right?
Yeah.
What's the sign of pi?
Zero.
What are you doing? It is 0 or 1, but which one is it? Sine is the y coordinate, so at pi, all the way over on the left side, it's 0.
That's what I said. You let me like I was saying.
I didn't. I was thinking about
That's why I
it.
changed my answer.
What? No, okay, but 2 times pi over 2 is pi. So the sign of pi. All right, now I've got pi over 4 times. Again, what's the cosine of pi? Close, -1. Go to pi on your unit circle in your head. Here's pi. -1. Equals. Yep.
All right, so we'll speed up a little bit. That one's square root of 0, too. No, it's not. That's what 1 half. So it's going to actually be up there on the top. I had to vision that.
Are you caught up, Noah?
It's 0.
All right, so cosine of pi over 2, because that's 0, because I'm up at the top, and the x coordinate there is 0.
All right, let's see.
Plus, okay, pi over 2 times 2 is pi.
That's -1.
So what's the negative sign of pi over 2? So,
Wait, times 2.
I already did that. Pi over 2 times 2 is pi. So this is why I don't solve for dy dx first whenever I'm doing a specific point, because it's so much easier to plug in. And this is gone. This is gone. So really what I have is negative pi over 4 dy dx. Bless you.
Equals negative 5. And then you can use like, 5. Well, you can multiply.
Multiply by the reciprocal.
And you'll get 4 pi over 5.
No, you. Oh, yeah.
No, you can do 4. Right?
It's 4. Okay, so that is the slope of the tangent line at the point pi over 4, pi over 2. But now it's easy to finish the problem, right?
Oh, that's not it.
Yeah. Well, it said write the equation of the normal line and the tangent line.
Well, that's your tangent slope, so you're just going to point. Hold on, wait. Use the regular slope too. I know that one.
Opposite.
Wait, the opposite reciprocal of the opposite reciprocal of the tangent slope is your long slope.
Yes.
Why did I not know that?
How did you learn this line?
I've done all right on the quizzes and tests.
We did an entire lesson.
It was snuck in there. I was trying to be all sneaky so that Billy wouldn't know how to find
It's like how
them.
Jim Locke told us that he told us evolution. He
Well,
never said
to
a
be
word.
fair, on the review packet, the next day I checked the review packet, it was on the front page of the review packet. That was like,
He never said that. He never said that in a lecture one day.
Every,
Don't light a cigarette.